Erosion is the transport of weathered material by wind, water, ice, or gravity. Erosion requires something to cause the motion: water, wind, ice, or gravity, and it has some sediment being moved. First we'll do water. Running water erosion is the most common, most powerful form of erosion on Earth's planet. Streams, fast-moving running water, carry sediment by being dissolved in solution. Small solids like clay, flower-sized particles, are carried in suspension, and larger solids like pebbles roll, slide, or bounce along the bottom. This is called saltation. Here you see an animation of all of these going on. And you can see how this rolling and sliding motion is why river rocks tend to be very round and smooth. Streams also produce a V-shaped valley. You notice here it's very steep. It's thin at the bottom. It doesn't widen up immediately. It doesn't bulge out early. It goes fairly steeply up to the left, and you assume similarly on the right. Waves also cause erosion. At the beach, we have what's called a longshore current. Waves rarely hit the shore straight on. They tend to hit at an angle. If you've been to the beach, you're familiar with this. Since they hit at an angle, it actually produces a current moving along the shore, thus the phrase longshore current. You see that in this picture. Since the current is moving this way, it actually draws the sand along with it. This is why if you stand with your feet slightly in the water at the beach, it feels like the sand's being pulled out from under your feet and then carried further down the stream, and the new stuff is buried. It buries your feet because all the sand is moving. Because think about it, if it can make you floating out in the water move down the shore away from your blanket, it certainly can carry some salt and sand. Now this longshore current can be a bit of a problem for people who live along the beach. The sand is constantly moving, so if there's a storm, the sand often washes away. So we have various methods to try and protect our beaches. Groins, seawalls, and breakwaters are three types of these. This is a groin. It is a long pier of cement and rock. Basically, it's just sticking out into the ocean a bit. And let's see what that does to the sand. The current's moving this way. It hits the groin, stops, and then the sand is deposited here. So all of the sand that's moving here gets dumped in Mr. Smith's land, and so he gets a bigger beach. Yay! But Miss Jones loses her beach. She's probably going to be rather irritated at Mr. Smith, understandably so. So what she's going to do, since she can't make him get rid of his groin, is she will build one. And then somebody else further down the current will have to build another one, and another, and another. Jersey Shore is covered with these. If you look it up on Google Earth sometime, it's really kind of funny. A seawall is usually done because you're afraid that the beach is going to erode away completely and take away your house. That obviously is a problem. So you build this up, build this wall, a seawall. It doesn't make a drastic change to your beach, though it does make some. And since it adds some to your beach, it's going to subtract some from Mrs. Jones. But it will certainly protect this area, so you don't have to worry about your house being carried away. Again, though, it is a problem for people further down the stream. Next, we've got breakwaters. These are called breakwaters. They are walls in the water further out to sea, like man-made islands, and that's pretty much what they are, small man-made islands. And they do protect the shore. But as you are no doubt starting to figure out, it protects your shore and grows your beach. It shrinks Mrs. Jones' beach. So anytime we play with the beach, we actually are causing problems that will probably hurt someone further down the stream. One example of this is Ocean City. We've all been to Ocean City, Maryland, enjoyed the beaches there. Well, that has a cost. The longshore current here flows south. A little while back, Ocean City decided to try and protect their beaches by building a jetty. This was before this parking lot was put in. They built a jetty here, a groin, to protect their beach. See what it did? This is the original location of this lower island. This lower island used to be here. But Ocean City's first groin grew their beach and shrank this island. And then Ocean City went, cool, we can make our beach bigger. Because see what it used to be up here? This is what the normal beach for this area should be. And notice how much larger it is here. They were so successful, they built another jetty, another groin. They extended it. And then they built one here to extend it still further so they could have a parking lot. They got lots of extra beach here that they shouldn't have. The people who used to live on this island, and yes, when it was here, it used to have houses on it. They got washed away because all this sand should have come down to this island. These groins blocked it all, so these people lost their homes. They tried suing Ocean City, but Ocean City has good money and good lawyers, so the people lost their houses. No luck whatsoever. And it's still moving further back all the time. This wall was built, I think about 10, 15 years ago to try and protect the island, but you can see that the island has moved still further even since then. Soon, this island will weld itself back here. Barrier islands are islands that form parallel to the coastline. They protect the land further in. They're, nature's seawalls. And they work very effectively to protect the land, to protect the beach. Wind is another thing that causes erosion. Through deflation, where the winds blow away small sediments, and sandblasting, where the force of the wind blowing sand against the rocks erodes them away. You can see that sandblasting very clearly in this picture, or at least the results of it. This rock here used to cover the entire area. Here we've got a little column left of it. But the constant blowing of the wind, slamming against the rocks, has ripped down what was here, and what was holding up most of this column. And it continues to. Soon enough, this will get eroded away, and this guy will topple over. The sandblasting tends to happen nearer the ground, though it does get higher when there are storms. But the main wind hits pretty close to the ground because sand can be heavy. And so in this image, we've got a chunk of basalt, which again makes up the ocean crust, and is being slammed into by the wind-driven particles. Which image, A, B, C, or D, shows what the cobble would look like after sandblasting? Hopefully you picked D. You can see that the area where the wind was hitting the most has been eroded away. Here, it looks like it grew, which makes no sense. You get slammed more with wind and sand, and that makes you bigger. No. Here, there's no change, and here it got bigger on the backside. Doesn't make much sense. It's going to get smaller where it's been sandblasted. Glaciers are large masses of ice and snow existing year-round, moving downward under the force of gravity. The snow, the ice that makes up the glacier, is constantly flowing down the hill. They're often called rivers of ice. They move slowly at the bottom because of friction with the rock, and faster in the middle center, but they do erode the entire area. As they slide along, they do something called plucking. When it hits a lump like this, it's moving across. Water breaks in, breaks it a bit. The ice freezes onto pieces of rock and carries it down with it. That's called plucking. Also, since it's carrying all of these chunks, and these can be pieces of rock it plucks, can be anything from the size of sand to the size of a bulldozer, the size of a car or a house. They can be huge. As they move across the ground, they scratch it. These scratches are called striations. And you can see from this rock that the glacier either moved left to right or right to left, not up and down. But you can see the motion of the glacier in it. Striations are thin scratches. Grooves are deeper scratches. And then you can see little bits here where something's been plucked out. That's plucking. The Finger Lakes are kind of neat because they are huge, long lakes. Kind of looks like Freddy Krueger got to the land here, or Wolverine. But instead of knives producing these, glaciers produce them. And these are a mile or more wide and 60, 70 miles long. So they are very long, very deep scratches. Here's a Google image of it. Deep blue, long lakes from the glacier pushing down and digging into the ground. It was unusually soft here. Finally, with glaciers, we get what we call erratics. These are large sediments, boulders, often, that are transported by the glacier. They're called erratic because they don't match. If you're erratic, you're crazy, you're weird, you don't belong. These erratics, if you can see in this image, it looks kind of like a cow. You got this great big boulder on top of three little ones. That doesn't make much sense. What happened is the glacier moved across the ground, picking up all sorts of stuff. Glaciers are like gigantic bulldozers or brooms. They sweep across the land, picking up everything from sand to, you know, half a mountain. And then when they melt, they just dump it all there. Kind of like when you're sweeping a really dirty floor. You get it all mixed up, some big stuff, some little stuff, all on top of each other. And that's what happened here. An unusually large piece got dumped on top of little pieces. This is an example of a typical advancing glacier. The snow is moving down the hill, and as it moves, it drags sediments across the bottom and across the top. Advancing glaciers happen most frequently when you're having an ice age. Most glaciers this time are retreating. That means that the toe is moving backwards. It's melting faster than it is being produced by the snow. And so it leaves lots of sediments in its wake. We also have stationary glaciers. Notice the ice is still moving, but the toe is not. And so this dumps all the sediments into one spot. These are called moraines. Finally, a glacier produces a U-shaped valley. Notice that this is a lot broader than the river valley, which produces a V shape. This U shape is typical of glaciers. Glaciers are also what produced Long Island and Cape Cod. As glaciers moved across New England during the last ice age, they scraped up all the crap, all the trash off of those areas and just dumped them here. From Cape Cod, here it got eroded away, washed away a bit, all the way down to Long Island. Finally, we have gravity. Gravity is mass movement, large downward transport of weathered material, and it can either be fast, like in this mud flow that unfortunately killed many people in El Salvador. It was triggered by an earthquake, happened within minutes, or slow, over the course of many years, a piece of land sliding down. Fast moving are usually called earth flows, mud flows, or landslides. And a flow implies there's more liquid, a slide, it's sliding. This is Mount St. Helens, the lahar mud flow caused when the volcano's heat melted the glacier. Here's an image of another one. Look at the trees. Fast can also be a rock fall. If you've ever driven through the mountains, you'll often see signs, beware falling rock. Just rocks break off of cliffs, and then at the bottom of most any cliff, there's going to be a pile of rocks dumped there, all mixed up, different sizes. That pile is called talus, Talus. Slow movement can be creep or slump. Creep, like the name implies somebody creeping up on you, really slow. Extremely slow, imperceptible, meaning you can't see it, movement of the soil down the slope. You don't see any motion in this picture, but these trees should be straight up. They don't naturally grow this way. They're growing curved because the soil is sliding down and that carries the tree with it, thus causing it to curve towards the light. That's what you see here. This slope is unstable. You don't want to build your house up here because if you do, the soil is going to slide down the slope. And so, eventually, so too will your house. This is a very, very important thing. Please, if you ever buy land on a hill, check for creep. No creeps. No creeps allowed here. Finally, we have slump. Slump is sliding in a lump. A whole chunk of the ground slid down. And you can see that in both of these pictures. It's a lump or block fell down. Now, each different measure type of erosion produces different shaped sediments. Running water makes them smooth and round. Wind, round but pitted, little holes where pieces have been removed by sandblasting. Glaciers, ice, semi-rounded and scratched, striated. And gravity leaves them sharp and angular. So in this picture, hopefully you can tell D is water, smooth and round. Next most obvious is glaciers. You can see the scratches on it. This one is wind. You can see the little pits, the little holes produced by the sandblasting. And B hasn't been eroded at all, hasn't been changed much at all. It's been changed only by gravity. It's very angular.